Good morning, students. This is a problem on relative velocity. A projectile thrown from a bank of a lake, this is a lake, with an initial velocity u at an angle theta with the horizontal. Find the relative velocity of the shadow of the projectile with respect to the projectile itself. That means you are throwing a projectile from the bank of a lake. This is a lake and this is air, and this projectile is going like this. The shadow of the projectile is going like this. You need to find the relative velocity of this shadow with respect to this projectile itself. So what you need to do, just what I have taught you, you need to go into the body frame of this projectile. That means you have to be in a rest frame of this projectile. For that, you need to add a velocity vector field exactly opposite to this, right? So that is minus v over t to keep this projectile stationary. So this velocity vector field will immediately be affecting this as well. Now this, since this is going like this, the shadow will be symmetrically going like this. So if this is Vt, the shadow of this will be going with like this, right? This will be also Vt, but there is a problem. See, this is in the first quadrant, this is in the fourth quadrant. Anyway, suppose consider this as V prime t, I will have a relation V prime t with Vt, and now with this V prime t you need to add this minus Vt, because this minus Vt is the velocity field which keeps this projectile stationary, right? So this becomes stationary. So what's the relative velocity? The resultant of these two. Concept is very simple. So this is the relative velocity. Now let's find the velocity here. You just break it into components. You know that if I throw this projectile with an initial velocity u at an angle theta with the horizon, this component u cos theta doesn't change. Why? Because there is no field in this direction, right? The gravitational field which make this projectile move in a projectile path, in a parabolic path, is acting vertically downwards. So there is no field in this direction, right? So this is u cos theta and this is u sin theta. These are initial velocities. Now what is this then? So this will not be changing, right? So u cos theta, so the component of this Vt along the x-axis will not change, but that this will be u cos theta, but the component along the y will definitely change. So what is this? Let's find the component along this. Suppose this is Vy. So what is Vy? Vy is u sin theta t minus gt, right? Very simple. And this is what? This is basically Vx. So what is V? So what is Vt? That is I Vx plus j cap, so I cap Vy. So that is I cap Vx is u cosine theta plus j cap times this thing, u sin theta minus gt, correct? So this is the velocity vector field, right? So you now need to add minus Vt to this. So this becomes stationary. Now what happens if this becomes stationary? This same velocity vector field is added to this shadow, correct? So this minus Vt, what's minus Vt? Minus Vt is minus I cap Vx minus j cap Vy. So that is minus I cap u cos theta minus j cap u sin theta minus gt, correct? So this is the thing you are going to add. Now you need to find this Vt. See, by symmetry we can easily see that if this projectile is moving like this, this is also moving in a parabolic path. So this V prime t has also a component along this direction and along this direction, right? So since this is just a shadow, this Vt will have a component. This will remains the same because this is going in this direction. So Vt will be I cap u cos theta, but the j cap component, this will be just minus Vy, right? So that's minus j cap. What is Vy? Vy is u sin theta minus gt. So this is V prime t. So what's the relative velocity of this with respect to this? Just apply vectors. So V relative means this projectile with respect to the shadow. So this P for the projectile, shadow with respect to the projectile. So this is S stands for shadow. I am not writing it. And this is for the P is for the projectile. Okay, so that's V relative. So that is, you need to add this Vt with V prime t. So V prime t minus Vt, algebraic adding it. So if you add, see, if you add these two, this u cos theta and minus u cos theta, so that's I u cos theta and minus I cap u cos theta gets cancelled, and you are getting this plus this. So that's minus twice of I, or let me write it explicitly, that will help you to understand. So let me plug in the values. So that is I cap u cos theta, so these are the values for V prime t, minus j cap u sin theta minus gt. I am writing this side, plus minus of this, minus I cap u cosine theta minus j cap u sin theta minus gt, correct? Now this term gets cancelled, so it gets twice j cap with a negative sign u sin theta minus gt. This is the relative velocity of this shadow with respect to this projectile itself. See, this is a function of t. Now let me analyze this. See, this is only along j cap. So this projectile will not realize that it is moving in the horizontal direction as far as seeing this shadow. Okay, it will only see this shadow going away with twice its velocity. This is very similar. If you have a mirror, if you have a horizontal mirror, and if you go away, you will see this fellow is moving away with twice its velocity. The horizontal component doesn't come into play. So the concept of this problem came into my mind while I was driving with my car, and I saw my car's shadow in a building made of glass. So I also realized that I'm not be able to comprehend the horizontal speed of my car only. Of course, with respect to the building I can see, But as far as technically saying, only seeing the image of my car, it is very difficult to comprehend the horizontal speed of my car. Only what I can see is if I am going like this, so I can see the car is going up and down, or sorry, means in and out with respect to the building. So that's the concept came into my mind. This is a problem which I have framed it. I hope you will enjoy it. Thank you very much.